Hello dear students, a very good morning to all of you. This is Dinesh Mehbubani. Welcome to the video lecture series of numerical methods in chemical engineering. See, we have started unit number 3, that is solution of system of linear equations. And in this chapter we have already studied about Gauss elimination method, then Gauss elimination with partial pivoting, then Gauss-Jacobi. Gauss-Jordan method is there, but in Gauss-Jordan you have to do it by yourself because you have already studied it in the previous semesters. Okay. After that we started the iterative methods. We know that what is the meaning of iterative methods. Iterative methods means the methods in which there are number of repetitions in which we have to find the different approximations, first approximation, second approximation, and so on. Okay, we are doing the same process repeatedly, that is known as iterative method, and we have started Gauss-Seidel method. Okay, to apply Gauss-Seidel method, the necessary and sufficient condition is that the system should be diagonally dominant. Now, what is the meaning of diagonally dominant? The diagonal should be greater than or equal to the sum of the other two elements of the same row. Okay, at least one diagonal should be greater. If other two are equal, then it's okay, but at least one should be greater than the sum of the other two elements. Okay, if this condition will not be satisfied, then we cannot apply this method. Okay, so to apply this Gauss-Seidel method, it is compulsory that the system should be diagonally dominant. Okay, so let us solve one or two numericals on the basis of this. Okay, see what is given. Here a system of linear equations is given. 10x plus y plus z equals to 12. 2x plus 10y plus z equals to 13, and 2x plus 2y plus 10z equals to 14. See, first of all we have to check whether it is diagonally dominant or not. Okay, so here you can see these three are the diagonals. Okay, so here we can say 10 is greater than 1 plus 1. Okay, it is correct. Then again 10 is greater than this 2 plus 1. Okay, this is also correct. Then 10 is greater than 2 plus 2. So all these conditions are satisfied. So we can say the system is diagonally dominant. And after that, from equation number 1, we have to eliminate x. From here eliminate y, and here eliminate z. So my equations for x, y, z will be 12 minus y minus z upon 10. Okay, then y will be 13 minus 2x minus z divided by 10, and my z will be 14 minus 2x minus 2y divided by 10. Okay, now as we know that in Gauss-Seidel method successive replacement is used. In successive replacement, what we are doing, we are replacing the old value by the new value in the same iteration. Okay, so the next step is to make a table. Okay, we have to make a table in which we will write first of all the approximation number, then xn plus 1, yn plus 1, and zn plus 1. Okay, if you want to write the formula, then also you can write it. What will be the formula for xn plus 1? 12 minus yn minus zn divided by 10. Okay, then yn plus 1 we have to replace the old value by new value. So 13 minus 2 into xn plus 1 minus zn divided by 10. Similarly, zn plus 1 can be written as, we have to place both the new values. So xn plus 1 minus 2y into n plus 1, okay, divided by 10. Okay, what is our next step? See, in this you have to select the decimal places at 4. By default you have to select 4 because nothing is given. So by default 4 should be selected. Okay, here initially we have to take 0, 0, 0 as our x0, y0 and z0. Okay, then to find the value of xn plus 1, okay, see this is the first approximation. 0, 0, 0 initial is already given, then xn plus 1. See here we have to take y and z as 0, 0 because the initial value are 0, 0. So 12 minus 0 minus 0, 12 by 10, that is 1.2. Okay, here which value we have to take? See 13 minus 2 xn plus 1 and zn. See what is our zn? See Zn is our this value, old value. So in place of Z we have to take 0, and in place of X, see we are not taking this value, we are taking this value 1.2. So to find yn plus 1 we have to use 13 minus 2 into 1.2 minus 0 divided by 10. Your answer will be 1.0600. Similarly for Z, what we have to do? We have to use xn plus 1. Xn plus 1 means what? We have to use the latest values. Latest values of x and y we have to use. Okay, so what will be the answer? My answer will be 0.9480. Okay, you have to repeat these steps until you get the two consecutive values same. Okay, now xn plus 1. Which are the latest value of y and z? So these are the latest values of y and z. So you have to use this. Okay. My answer will be 0.9992. Okay, here again use the latest values, so you can find the answer 1.0054, then 0.9991. See, in this way you have to use the latest values and you can get the answers. Okay, you have to solve it by yourself. Up till which value you have to find the answer? See, in this sum the values of x, y, z become same. Okay, here 1 is there, 1, 1. So 1, 1, 1 is the solution of this. But in some cases, if they are asking an accuracy of 3 decimal places, then what you have to do? Fix the digits at 5 and continue this until the 3 digits consecutively comes same. Consecutive means what? 3 and 4 in each and every expression should be same for x, y and z for all, right? So to apply the if there is 3 decimal places asked, then you have to check, okay, up to 3 decimal places the digits should be same. Okay, but in this case nothing is asked, so what we are doing, we are stopping here because we have got the same solution. If you are not getting the same solution, then you have to solve till 5 to 6 iteration and then you have to write the answer. Fine. Okay, see, let us solve one more numerical. See what is given. See, the numerical is given in the matrix form. See, ax is equal to b is already given and the initial approximations are already given. X0, Y0, Z0 is given. Okay, so from this you can make the equations. First of all, you have to check whether it is diagonally dominant or not. Can you check it is diagonally dominant or not? See here, 2, this 2 and 1. See, this 2 is greater than 1. Again, this 2 is equal. This is equal. At least 1 should be greater. Okay, this 2 is greater than 1 plus 0. So 2 is greater than 1 plus 0. It is satisfied. Okay. Again, 2 is equal to 1 plus 1. It should be greater or equal, right? Then 1 is equal to 1. So these conditions are satisfied, so we can say it is diagonally dominant. And once we know that it is diagonally dominant, then we can apply the formula. Okay, see how you can write the equations from this. The equations can be written like this: 2x1 plus x2 equals to 1. Then second equation can be written like this: x1 plus 2x2 plus x3 equals to 2. And the third can be written like this: x2 plus x3 is equal to 4. And using this, you can write the equations from of x1, x2, x3 from this. What will be x1? X1 will be 1 minus x2 upon 2x1. Okay. x2 can be written as 2 minus x1 minus 2x2. 2 minus x1 minus x3 will come here, divided by 2. Here also divide by 2 will come 1 minus x2 by 2 here. 2 minus x1 minus x3 divided by 2, and x3 can be written as 4 minus x2. So these are the three equations. Okay, and using these three equations you have to find the answer. Fine. So here I am making a table, approximation number. Okay, then x1, x2 and x3. See here we have to start from the initial gas. The initial gas is already given. So you have to start from 1, 2 and 1. Okay, fine. So we have already found x1, x2, x3, and then you have to find the answer. Second approximation, you have to use these values as the initial values. After finding this, you will get the answer like this: minus 0.5, 0.75, 3.25. Okay, here it is given you have to carry out 4 iteration. Carry out 4 iteration means you have to find up till 5. Okay, because this is already given. So you have to carry more 4 iterations. Okay, you have to carry more 4 iterations. So you can check your answers. I am just writing the answers of each and every iteration. Then 0.8438 minus 1.7657, 5.7657, and the last is 1.3829 minus 2.5743 and 6.5743. See here there is no need to check whether the digits have become same or not, because it is already given that you have to carry out 4 iterations. So you have to stop here. Okay, there is no need to solve further, and there is no need to check the digits even. There is no need to check the digits have become same or not. Okay, so in this way you can solve this numerical. Let's move on to the next method, and the last method of this chapter, Gauss-Jacobi method. Okay, now what is the basic difference between Gauss-Jacobi and Gauss-Seidel? The basic difference between Gauss-Jacobi and Gauss-Seidel is the Gauss-Jacobi is slower than the Gauss-Seidel method. Why? Because in Gauss-Jacobi we are not using the successive replacement. Okay, the successive replacement is not used. Now what is the meaning of successive replacement? Old value is replaced by the new value in the same iteration. Okay, in the same iteration we are replacing the old value by new value. That is known as successive replacement. But in Gauss-Jacobi the successive replacement is not used. So this method is slower compared to the Gauss-Seidel method. Okay, so directly if we write the formulas of x, y and z, the formulas can be written like this. Okay, in this case also the system should be diagonally dominant. Okay, to apply Gauss-Jacobi or Gauss Siddle, the necessary and sufficient condition is that the system should be diagonally dominant. Okay, so in this case also, first of all, we have to check for the system. Okay, it is diagonally dominant or not. Let me write the equations for x, y, and z. A12y minus A13z, D2 minus A21x minus A23z, and here D3 minus A31x minus A32y. Okay, this is the equation. Now, if I want to find the first iteration, if x0, y0, z0 is given, okay, x0, y0, z0 is given, and I want to find the first iteration. So if I want to find x1, y1, z1, then here I have to write y0, z0, here x0, z0, and here also x0, y0. Did you get the difference? What is the basic difference? Here we are not using the new value. We are taking x0, y0, z0 in all the values. Okay, in x1, y1, z1, we are taking x0, y0, z0 as the previous iteration. Okay, so in this way we can say it will take more time. Why? Because we are not considering the new value. While finding y1, okay, we are taking x0. As we have already found x1, we are not taking the x1. We are taking the old values. Okay, we are not replacing it by new value. So this is the basic difference in the formulas of Gauss-Seidel and Gauss-Jacobi. Okay, here we are taking the old values. Okay, as the successive replacement is not used, so it will take more time to converge. Okay, so on the basis of this, if I want to write the general equation, okay, if I want to write the general equation to find the iterations, then it can be written as xn plus 1, yn plus 1, zn plus 1 is equal to 1 upon a11 d1 minus a12 yn minus a13zn 1 upon a22 d2 minus a21 xn minus a23 zn. Here we are not taking xn plus 1, okay. 1 upon a33 d3 minus a31 xn minus a32 yn. So these are the general equations to find the solution of a system using Gauss-Jacobi method. Okay, it is more time consuming because we are not taking the new value, we are continuing with the old value. Let us see one numerical on the basis of this. Let me write the equations. Two x plus 2y minus 18z is equal to 30 and x plus 17y minus 2z is equal to 48. See, first of all, we have to check whether it is diagonally dominant or not. See here, 60 is greater than 6 plus 4. Here 2 is not greater. Okay. Here 17 is greater, right? But here 2 is not greater. 18 is greater. So you can see we have to rearrange the equations. By rearranging the equations, we can make the system diagonally dominant. Okay. So rearranging, how to rearrange? We have to interchange the second and third equation. So after rearranging, I can write 60x minus 4y plus 6z is equal to 150. X plus 17y minus 2z is equal to 48. And now my third equation will be 2x plus 2y minus 18z is equal to 30. See, now you can see it is diagonally dominant. Here 60, 17 and 18. Now it is diagonally dominant. See, if you will not rearrange, your whole answer will be incorrect. Okay, so you have to first of all rearrange to make it diagonally dominant. and from equation number 1 find x, from 2 find y, and from 3 find z. So what will be my x? My x will be 150 plus 4y minus 6z upon 60. Okay. My y will be 48 minus x plus 2z upon 70, and 30 minus 2x minus 2y upon minus 18 is my z. Okay, then what I have to do? I have to make a table, okay, in which the first will be approximation, then x, y, z. See, if you want, then you can write the whole formula, or it is not compulsory to write the whole formula. Here you have to fix the digits in the calci as 4. Okay. Here we have to use the old values in the approximation, right? The first value we are taking as x000. Okay, to find x, we have to take y and z as 0. So my answer will be 2.5000. Then here again to find y, which value of x we are taking? See, we are taking this value. To find y, take these values. To find z, we have to take 0. We are not taking the new value, mind it. Okay, so my answer will be 2.8235. I am directly writing the all answers. You have to do it by yourself and write the answers. This is the solution. You will take little bit more time and the number of iterations will be more because we are not taking the new value. We are continuing with the previous value, so it will definitely take more time. Okay, 2.7760, 2.5341 minus 1.0767. Okay, then 2.7767, 2.5335 and minus 1.0769. See, here you can see two digits have been same after the decimal point. See, here the solution will be very long. So what you have to do? Solve up to 6 iteration, or you can stop if the two digits after the decimal point have become same. Okay, so here we complete our chapter number 3. Okay, solution of system of linear equations, in which we studied about Gauss elimination method. Okay, Gauss elimination with partial pivoting, Gauss Jordan, you have to do it by yourself, Gauss Seidel method and Gauss Jacobi method. Okay, in the next lecture we will continue with the last chapter of the syllabus, that is chapter number 7. Okay, till then have a good day. Bye bye. Do some practice.